Hello class, this is Mr. Griffith, and this lecture is on topics of converting mathematical formulas to Python code and also formatting numerical outputs. So the problem we're using is on page 62, converting a math formula to a programming statement. So if you haven't read that, I recommend pausing the video, taking a minute and reading through that. Make sure you understand what we are trying to do here. And if you miss it, it's in the spotlight, so it's the background of this problem is grayed out in the book. Okay, so what the problem states, I have it written down right here. Suppose you want to deposit a certain amount of money into a savings account and leave it alone to draw interest for the next 10 years. At the end of the 10 years, you would like to have $10,000 in the account. How much do you need to deposit today to make that happen? You can use the following formula to find out. Okay, so we want to deposit a certain amount of, well, let me take that back. We want to have $10,000 at the end of 10 years, but pretty much we want to put money into account and not touch it and just let it gain, let it compound the interest until it grows to $10,000, and we want to find out how much that will be. So here's the formula we can use. P equals F divided by 1 plus R to the nth power. So the problem also describes what these variables are, so don't be too freaked out. This is algebra. No, algebra sometimes makes people freak out, but Python actually makes our job easier once we get it right. So P is the present value, so that's the amount we need to deposit. So that's what we want. That's what we are looking for. So that's good. It's by itself on the equation. That means this will give us that. F is the future value that you want in the account. Okay, so in this case, the future value, we want to have $10,000. So F is 10,000. R is the interest rate, 5%. And N is the number of years that you plan to let the money sit in the account, which is 10 years. So I chose 5% here just because that's a reasonable interest rate, but really you could use any interest rate for the purpose of this problem. So let's start programming here. The way I do that, I'm going to bring up idle by just searching for idle. Click it. And we have the shell right here, but that's not what we want. We actually want to create a file so we can enter more than one Python statement at a time. Okay, so here we go. We have a blank, fresh canvas, if you will, to work. So you may ask yourself, if we care, if we have such specific parameters, $10,000, 10 years, things like that, why use a formula at all? Why not just plug these in and have your Python program calculate that for you? Because you could easily hard code 10,000 in for F and just do it one time, one and done, you've got it. Well, the beauty of a programming language such as Python, well, any programming language, any computer program, is that you can create a formula like this that's very general, that takes input from a user, and then you can make it work many, many times for many, many different scenarios. So that's what we're going to do here. And this $10,000 is just one scenario of pretty much an infinite number of possibilities the user could use this for. Okay, so to make that happen, we need to get some input from the user. So first we need to find the future value from the user, or basically we're asking the user, hey, how much money do you want to have in the future? And yeah, in this case it is $10,000, but we want to make it very flexible. So that's the first one. We also, we could also do the interest rate. So interest rate might not always be 5%. So let's also get that from the user. And same thing for years. Hey, years might not always be the same. So let's go ahead and get that from the user as well. Make this very flexible. Oops. Okay, so one thing to mention, notice what I'm doing here. So this input tells Python, hey, stop the program here and actually require the user to enter some input through the keyboard. And when you press enter, it will store that input in whatever variable you've set it equal to. So when the user enters something after enter the annual interest rate, they enter an interest rate and hit enter, this rate will now hold that value. And float, so is not 100% necessary, but in this case it's good to be specific. So Python will store this value pretty much the best way it knows how if you don't tell it. Float tells Python, hey, we are expecting a number here, and not just any number. Float has decimals. So an interest rate will have decimals. We don't expect the user to enter 5%. We want them to enter 0.05 for 5%. That is a decimal. Same way with the desired future value. Maybe they don't want an even number. Maybe they want one with decimals. Years is a little different. We normally don't think of years having decimals, so we're going to expect an integer. That's what int stands for, which is pretty much a whole number. If you're unfamiliar with what an integer is, feel free to Google that and you'll find some great answers out there, better than I can give. So we have all the information we need to perform our calculation, and we'll call that present value. So when you're typing in an equation into Python, you kind of want to read it from left to right or top to bottom. So this formula doesn't really have a left to right. It really jumps right into the top to bottom because it is a fraction. Now the bottom part of the fraction, the denominator, actually does have some pieces that are separated by a plus or minus, so that would be read left to right. So first thing we need is f in the numerator, and we called that future value. And we use this as a division sign, and I always like to include my entire denominator if it contains more than one item in a parenthesis. So that's what I'm going to do. So that means we're going to divide future value by everything in this parenthesis. And what do we need to do? Well, we need to add 1 plus the rate. And then we need to raise that to n, which in this case is years. So n in this case, as you can see, n is the number of years. So here we're going to use years. So let's print that out. Let's see if that works. We're also going to print some nice helpful text along with this. Tells the user, hey, here's what you're getting. So let's run this. Oh, and to run, we always have to save. So let's save it. I'm just going to save it on the desktop. Call it demo. Oops, I actually already have one of those, but I'm going to replace it. So here we go. Let's just go with the scenario they described. So $10,000, interest rate 5%, which is 0.05, and we want that money to grow for 10 years. So comparing my answer to the book, looks like we're doing good so far. We need to invest $6,000 at 5% for 10 years, and we'll end up with $10,000. It's not too bad. Actually, that's almost doubling the money. Not quite, but almost. So we're doing a good job. We've done this correctly so far. Now let's actually format that number output. The way it stands, you'll never see, as you know, when you look in your bank account, money doesn't have this many decimal places. We know that the penny is the smallest value, so it only goes to 2 decimal places. So let's format it to make it a little more realistic. So on page 68, there's a section called Formatting Numbers. If you haven't read that, I would recommend pausing the video, reading that section over. There are many different ways you can format numerical output, but all of them use the format function. So they all are very similar. So present value is what we want to round. So let's do that using the format function. The format function takes the first argument is the actual value we want to round. So that would be present value. So let's do that. And the second argument is the format that you want to round that to. So the way we do that, in this case, the decimal 2 tells Python that you want to round it to 2 decimal places, and the letter F means that we are rounding a float. Now I know that's a float because that's what we passed into the function, and floats have decimal places, so therefore I'm confident this is a float. So let's run that. Let's see if that works. Save it. Oh. So this is good. It looks like I am missing something here, and the question is what? So unexpected EOF while parsing. Error is not super helpful, but the location is. It gives me a highlighted red line there to take a second look. And oh, I see what I did wrong. If you notice, an open parenthesis always must be, you can never leave it hanging. You've always got to close it with a closing one. So I see that I did not close this first parenthesis. There we go. So when you do that, it will show you this highlighted section that, hey, yep, you closed that parenthesis. So let's try this. Okay, so that looks good. We have now been rounded to 2 decimal places. But we can take this one more step further. This is money we're dealing with here, not just any number, it is money. So let's try to put the actual money symbol in front of this. And the way we can do that is just by putting it directly in this string. So this print statement is taking this string here, and it is adding the number we're formatting to the end of it. And you can do this in the print statement for as many different values as you want. I could do this again, and I could say comma hooray, and it would print hooray at the end of that number. And I can do that because I put a comma here. Now one thing it does though is, well, I will just show you what the comma does. So let's enter in our values. So notice what happened. I have a $sign here. I don't have a space, but yet there's a space between the $sign and the numerical value. So that's not exactly what we want. The default functionality is for it to insert spaces anywhere it sees a comma in this print statement. Now we can tell it not to do that with a special command at the very end of the print statement. We must put a comma after our last value or parameter in that print statement, and we put this SEP equals 2 single quotes with nothing in them. So that is pretty much telling it the separator needs to be nothing. There needs to be nothing there to separate it. So let's see if that worked. Okay, there we go. So it now, instead of putting a space in between these two values with the comma where the comma is, it was now going to put an empty nothing there, which will take that space away. Okay, so if you have any questions on this example, please feel free to reach out. And also, if you see any other topics in the book or in this chapter that you're not quite sure about, feel free to let me know, and I'll be more than happy to make a custom lecture video and post it on Blackboard. Thank you.